This building is 62 feet high, 72 feet wide, and 120 feet long. It's located about 5 miles north of Charlevoix, Michigan at Big Rock Point. There's nothing unusual about it to distinguish it from any other new turbine generator building in the Consumer's Power Service area, or anywhere else for that matter. Inside, the turbine generator is not a spectacular piece of machinery, now that it's assembled and installed. There's no movement to see, only a steady hum to hear. The administration building at Big Rock Point is well designed, handsome, modern, but it's a lot like many industrial structures. It houses the control room. There are offices and other rooms too, but the control room is the most important. Only an experienced eye would be able to notice anything different about these panels. In most respects, they're much like those in any other power plant control room. But this is different. This is not at all like what you'd expect to find at an electric power plant. It's the new shape of a new kind of plant. Inside is the equipment for a new technology, nuclear power. Here is where Consumers Power Company and its customers are getting an adventurous and challenging head start on tomorrow. The stage, the screen, and television often bring you stories of high adventure, fast-moving action, and powerful drama. Right now, I'd like to bring you a different kind of story. In its own way, it's just as dramatic as anything a writer could dream up. What's more, it's important to us all, because it has to do with a new power source that will influence the future plans of our electric utility companies. This power source is the atom. Nuclear power has made tremendous strides in our country in the last few years. Even though we're inclined to think of nuclear power as new, it's important to remember that it has been proved in many applications. The Skipjack, world's fastest submarine, launched in 1958, is powered by an atomic reactor, as are 23 other submarines in the Navy's underseas fleet. The aircraft carrier Enterprise, mightiest ship ever built, uses 8 reactor units. And in our merchant marine fleet, the Savannah, also propelled by nuclear power, is designed to carry 10,000 tons of cargo. Across the country, several atomic electric plants are in operation and others are nearing completion. The world's first full-scale atomic electric plant devoted entirely to peacetime purposes, as Shippingport, Pennsylvania, has been in operation since 1957. The Yankee Atomic Electric Company's installation at Rowe, Massachusetts, is supplying electric power to customers in the New England states. The Consolidated Edison Company is operating the Indian Point plant on the Hudson River above New York City. This is one of the largest nuclear plants in terms of electrical capacity completed by a utility company. Right here in Michigan, we have the Enrico Fermi Atomic Power Plant near Monroe. Consumers Power Company is associated with this reactor project, which is connected to Detroit Edison generating facilities. And the Commonwealth Edison Company's Dresden Power Station near Chicago has been on the line since 1960, producing, of course, the same kind of electricity that a conventional power plant produces. Which brings us to an important point. There's nothing mysterious about an atomic power plant. Basically, we're just using a new heat source. The standard fuels used in the production of electric power have been coal, oil, and natural gas. In the atomic power plant, we're using a fourth heat source, atomic fission. Atomic fuel has 2 advantages. It isn't consumed rapidly like other fuels, and it's very compact. For instance, the heat output of 1 pound of uranium can equal the heat output of 70 tons of coal. In the Big Rock Point nuclear plant, the heat produced by uranium fission is used to turn water to steam. The steam is passed through a steam drum to remove excess moisture. The resulting dry steam goes on to the turbine, where it spins the turbine blades. The turbine drives the generator and electricity flows to the transformers and the distribution network. Once the steam has done its job in the turbine, it's turned back to water in a condenser. The water is pumped back to the reactor to be turned into steam again. Every furnace has to be regulated, and the atomic furnace is no exception. You regulate the heat output with control rods. As they are moved down and away from the fuel core, the fission process produces more heat. Inserting the control rods all the way shuts the furnace off completely. Remove the rods, it starts up again. Before we can get our furnace going, we've got to get it into place and then put fuel in it. Early in 1962, the reactor vessel arrives at the plant site from Chattanooga, Tennessee. Working in bitterly cold weather, men and machines nudge the vessel into the sphere, inch by inch and foot by foot. After 4 days, the vessel is raised to its upright position. It took 2 years to build. Any damage now would jeopardize the entire plant schedule. Slowly, the vessel is lowered into its nest of steel, concrete, and huge pipes. Finally, it's in place. No time is lost in outfitting the furnace with its hardware. Underneath, the control rod drive equipment is added. Quarters are cramped. Inside the furnace, men install the grids that will guide the fuel bundles into place and keep them in proper alignment. Clean, white work clothes are worn to help keep the interior of the vessel spotless. Cloth caps and shoe covers are also worn. Every night, the opening of the vessel is covered with plastic film to keep out dirt and dust. Check-in time in the morning. Every day sees more and more technicians, fewer and fewer construction workers. The furnace is just about ready for the fuel. 2,400 miles away, the fuel is ready for the furnace. At the San Jose, California plant of General Electric, fuel bundles for the big Rock Point plant are brought out of storage. Each bundle contains 144 tubes filled with small pellets of uranium oxide. Shipping containers were especially designed to carry each bundle safely and rigidly on its journey over the mountains and across the plains to northern Michigan. The shipment arrives at the plant on time and in perfect condition. Each fuel bundle is worth upwards of $20,000. After careful inspection, the fuel is placed in storage at the plant, but it won't be there for long. Outside, the finishing touches are put on the plant. Construction is over. Acceptance testing has been going on inside as plant personnel familiarize themselves with the mechanical equipment. But in a sense, they've just been practicing until today. And today is September 27th, 1962. Today, for the first time, we'll know whether all the planning and design, all the time and effort will pay off. Today, we will attempt a controlled chain reaction. In nuclear terms, we will go critical. The first of 7 fuel bundles goes down into the water in the reactor vessel. The control rods are fully inserted. No reaction can take place until they are lowered. All eyes are on the control room. The control rods are lowered slowly. And as expected and hoped for, the nuclear reaction takes place. It's a big day at Big Rock Point. The atom has been put to work on schedule. In the Big Rock Point Information Center, visitors learn a lot about the atom and how its energy is used to make electricity. During the summer months, thousands of people visit the center every week. From the balcony, you can see much of the activity around the plant. And you can see also the scenery for which this area is famous. Few of the visitors had a chance to see the big rock itself back in the fall of 1959, a few months before the Bechtel Corporation, engineer-constructor for the project, started work on the site. By July 1960, the hole for the sphere had been dug and construction was underway. What does it cost to put up a plant like this? The concrete work, steel work, and other items connected with erecting the buildings run close to $6 million. The turbine plant, nearly $5 million. The reactor equipment, over $11 million. Other items bring the total up to $27 million. For 4.5 years after first operation, Big Rock Point will be a center of research and development work conducted for the Atomic Energy Commission. This work will be performed by Consumers Power Company and General Electric Company. One goal is to make the nuclear fuel last longer. Another is to reduce the cost of fabricating the fuel. More and more heat will be developed in the core, the heart of the atomic furnace, without increasing its size. These are essential objectives in the effort to make nuclear energy fully practicable as a heat source for generating electric power. Consumers Power is one of 124 investor-owned electric utility companies that are paying nearly $750 million to gain actual working experience with this new fuel well in advance of the day when it will be needed. Looking ahead is not new for the electric industry. They must always put money into new plant and new techniques ahead of the need. And the Big Rock Point nuclear plant may well be one of the industry's most productive achievements. Nuclear fuel, as it is used at Big Rock Point, is very likely to become economically competitive with coal. That day, that tomorrow, may seem a long way off to us now. It isn't. Not in the technology of power production. Consumers Power knows this. They've invested money, time, and manpower to build a power plant for northern Michigan. They've invested money, time, and manpower to gain a head start on tomorrow.